Hi everyone. So first I apologize because I don't really have any slides or like this is not like a real like prepared talk because I was in a jet lag. I just woke up at like 6. But I hacked up this like quick little app, and what this does is it shows you what Vue templates, Vue 2.0 templates are compiled into under the hood. And I think that this is something that kind of, once you start to use Vue more and more and you are either used to the template syntax, but you want to understand how Vue 2.0's render cycle works under the hood, this would be really helpful. So, and a lot of times during debugging, if you have like syntax errors or just logic errors in your templates that throws runtime errors, you would actually get pointed to the generated render function instead of the original template. So this is sort of like the thing you can sort of reason about the relationship between the generated code and your template. But before we go into any of this, so how many of you have like used Vue to some extent? Okay, so I assume it seems like some of you haven't used Vue at all, if that's the case. Okay, all right. So I guess I'm not going to just like reintroduce what Vue does, but like you can go to the website and see what it's really about. But the biggest thing about Vue 2.0, and is probably the only framework that does this, is that we use templates, but we also support raw render functions. And what are render functions? Render functions are, so if you've used React before, you know React has this thing called virtual DOM, right? And the thing about virtual DOM is that it has a virtual representation of what the DOM should look like. That's stored in memory. They're just like JavaScript objects that represents what the DOM should look like. And React uses JSX, but JSX is just syntax sugar. It compiles into raw JavaScript under the hood, which is the same thing as these render functions. And if you look at the compiled code of React JSX, you will see a lot of calls to react.createElement. And the return value from react.createElement is a virtual node that represents a node in your virtual DOM, right? So Vue 2.0 under the hood uses the same concept of virtual DOM rendering. And what we do is, so how virtual DOM works is when your app renders, it first renders the virtual DOM, and then on the first initial render, it will walk that virtual DOM and generate corresponding real DOM elements and then insert them into the document. On subsequent renders, we will generate a whole new virtual DOM. So we basically, on every render, we produce a whole new copy of the previous virtual with different state, right? So we produce a different virtual DOM, and we will compare the two virtual DOMs, basically do a diff process to figure out maybe an attribute changed, maybe a prop changed, maybe a class name changed, right? We figure out what has changed, and then we apply those things. This is a process called diff and patch, right? So a lot of more lighter weight implementations actually don't differentiate between the two. It's just like a one-pass thing. You just walk the virtual DOM, compare it, and patch it. So to actually do that, of course, we need to generate the virtual DOM, and this is what the render function does. So Vue 2.0 compiles your templates into virtual DOM render functions. And that's how it works under the hood. So I kind of want to explain. So let's take maybe the simplest example. Let's just render a single div, right? You'll see that we generate a render function, and it uses this with this, like what is this with this, right? Like, turns out the reason we're using with in the generated code is because the scoping rules of with aligns perfectly with templates. So if you look at, so let's say we are trying to insert an interpolation here, right? So we're trying to get the message on the scope of our current Vue instance. And when you generate it, because we're using with this, right? Every direct identifier you're referring to inside the render function will be first checked against this. So the scoping rules is basically exactly the same. So when we are parsing and generating these render functions, so we get this raw expression, and when we're generating the code, we don't need to do anything about it. We just put it verbatim into the generated code here. So this _s is just a helper to like turn undefined and null into empty strings. So imagine if we don't use this, right? What happens if we don't have this with block, right? So the message will be referring to a global variable, right? That's terrible. You don't want to accidentally leak to global variables in your render functions because your template is naturally, it should be scoped to your Vue instance it is associated to. So, but so with kind of naturally gives us this flexibility. And another important, interesting part about with is this that we're using here. It doesn't necessarily have to be the Vue instance itself. So during the development mode, Vue uses a pretty interesting trick, I would say, we create a proxy, an ES6 proxy object of the instance itself. And when you use with it, every message, like say this variable here, when the JavaScript engine evaluates it, it will first check if message is a property that exists on this with scope. And because this is a proxy, we can intercept this check. So the proxy can intercept a has interceptor. So we basically get to decide whether the user is allowed to access this variable at all. So we can do, say, a black list of global variables, or we do a white list of global variables that you can access. And essentially becoming a sandbox mechanism, but only in browsers that supports proxies, of course. And in production, this check is just stripped away because it doesn't need to be in production. So with is pretty cool, but people will complain that it's a deprecated feature. It doesn't work in strict mode, right? So the biggest problem is when you compile your Vue components into raw JavaScript and try to include with an external bundle, you run into the problem, say, hey, my bundler put this use strict at the top of the whole bundle. Now my code doesn't work anymore. So yeah, we can, so we added so go back a little bit. Like the reason we used with, right, is because the scoping rules aligns. So the benefit of this is it saves a lot of complexity in the compiler itself. Like when we're generating code, we don't need to figure out how to properly prefix this. Like instead of, if widths are stripped, we will have to do this, right? We'll have to first save a reference to the VM and then prefix every single variable that appears in the render function with the VM. And this is what if we were to do it properly, this is what we'd do. And this is in fact what we're doing in Vue Loader. But why don't we do it by default? Because using with allows us to dramatically reduce the complexity of our code generation process. So this allows Vue to ship a template parser compiler code generator in under 7 KB gzipped, right? That's the compiler itself, 7 KB, we include in the standalone build, and the standalone build as a whole is 25 KB gzipped. And this compiler, although lightweight, we can still, strip it. So the runtime only build without the 17 KB, without the compiler is 17 KB gzipped. So the compiler itself is, we are able to create a compiler that small with all the features Vue, all the syntax, all the supporting all the Vue syntaxes in under 7 KB because we are using with. But with has its problem. So how do we get the best of both worlds? So the idea is we add a post-compiler process where that's only applied if you're using a build tool. So if you're using the standalone build in the browser, you're not going to face the problem of including the compiled code into your whole bundle, which is using use strict, because the in-browser build will always work. Because width is always going to be available for global scripts, right? So we don't need to strip the width. But during the build time, we have the liberty of including a proper compilation pipeline. We can include a proper parser that parses JavaScript into AST, and then we can analyze the scope. So maybe some of you will be wondering, like, why can't we just do it with, say, like regex? Like, we can find all these, identifiers in the generated code and just prefix them. The problem is it's actually more complex than that, because once you have things like, let me just code this real quick. So now we have a v-for loop, right? The generated code, you will see that this L helper is basically the array.map equivalent, right? Internally, it uses a for loop, so it's a little bit faster. But this is an internal helper. So you can see this is actually, there is a nested anonymous function here, right? So this function introduces the complexity. It has its own scope because it has an argument here, right? So inside here, if we make use of that argument, you'll see that this item actually refers to this argument, so it should not be prefixed. And with width, right, there's no problem because JavaScript engine figures out what to do. But if we were to prefix it ourselves, as you can see, with proper prefixing, this item should not be prefixed because it's in scope, right? So you need to actually properly parse the AST and do scope analysis if you want to prefix these things properly. And to do that, you will ship a ton of code, which is just not practical if you want to do it in the browser, because you want to keep the library itself lightweight. So we do it in the post-compiler process, where we use a lightweight ES 2015 compiler called Buble. It's like the lighter weight alternative to Babel. So Buble is really fast, really lightweight, but it doesn't support plugins. So I basically forked it and hacked it, and to make it do what I wanted to do, I just have a forked Buble that has some hard-coded code that allows us to just strip the width, and this is the code that's produced after we doing this post-compilation process. So now we get the best of both worlds. We have a lightweight compiler in the browser that's only 7 kbg zipped, that does everything that Vue is supposed to do. But in production, we can generate code that's fully strict mode compliant, not using deprecated features, and a little bit more performant as well. So, so this is kind of like this interesting little internals of Vue's compilation strategies. And this is also I think this whole thing also kind of speaks the idea about the Turing. I would say it's like the underlying like semantical consistency between templates and render functions. Like when people talk about JSX and templates, they naturally think they are against each other, but in fact they are logically really the same thing. They are both declarative. They're both systems that allows us to declaratively declare the relationship between the state of your app and the final DOM output that you want on the page, right? As you can see, both of these, like there's a little bit like variable assignment here, but really there is not any imperative code here. Like everything is just like calling functions and returning stuff. They're just nested expressions. There's no real imperative logic in here. So this is actually also very declarative. It's just returning a representation of what the DOM should look like. And this is also declarative because, I mean, templates, right? You don't put too much logic in it. So that's actually what I wanted to talk about. I really hoped I could have more time to, structure it more, to kind of give it a better structure, but this is really what I plan to talk today, so thanks. Yeah, and this will be on GitHub soon. I have already deployed it to now. You can go to Vue template explorer.now.sh to just play with it. And yeah.
Hey, thanks for the talk. Could you add a child tag just right next to this pen tag? Very curious of what would happen on the right side of the screen.
To add a what?
Another child.
Another child next to the span?
Yeah.
Sure. Oops. So here is the, this is the starting of the children array. And this, whoops. Wait, what did I do? What did I do? Okay, so this is the whole expression that renders the v-for loop. And after the v-for loop, you have an extra p children in the same array. So under the hood, you will see this whole array. This whole array is the children passed to the div, right? So, and because the return value of this list helper is also an array, we have a nested array problem. Internally, Vue will normalize the children, basically flatten all the arrays so that they're all in the same array. And on the flight to Paris, I actually was looking at this problem because flattening arrays can be pretty expensive, and because we have to do it, we're basically doing an iteration and copy of every children array in the whole virtual DOM, and that's actually pretty expensive. So one of the interesting thing about JSX versus templates is often JSX proponents will talk about how flexible, how powerful JavaScript and JSX is, as if templates don't have any good parts about it. But one important aspect about templates is they are very, very statically analyzable, right? So we can do a lot of smart things. For example, in Vue's compilers, this P, if you give it a bit more static content, you will see it goes away, becomes this M function. Like what does this M function do? So because Vue's compiler detected that this tree is purely static, it doesn't ever change. So Vue's compiler is able to just hoist it out, cache it somewhere, and on subsequent renders, we just always reuse it. We don't even re-render it. So in the patch process, when you encounter a node that is marked as a static tree, the whole patch process can just stop and skip that whole part. So imagine you have a huge ton of static content without any data bindings in there. In a naive virtual DOM-based implementation, you would still, on re-renders, you would always have to still walk that tree, diff everything, just to make sure things didn't change, because with JSX, you cannot, the compiler is not smart enough to figure that out. But with templates, we can. Right? That's one thing. The other thing is the normalization issue, right? Because it's possible to, even if we are handwriting render functions, we will often end up with nested arrays, and Vue will normalize those for you, which is great. But in templates, for example, for an element like this, right? Just by looking at the template, we know that there is no nested arrays in the children of this div. So because of that, we can just skip the normalization process altogether. So on the plan, I basically did, what I did on the fly here was adding this this detection so that we will skip the normalization process whenever possible. And that alone was able to increase Vue's overall performance by around 5%, which is only possible because you have templates. So yeah, just some thoughts. Yeah. The mobile version of Vue? Vue itself, well, there is no dedicated mobile version of it because you just use the same Vue. It's already pretty lightweight for mobile applications. A lot of people I know use it. There are several solutions. I know there's Mint UI, which is a now supports Vue 2.0. Great. Thanks. Sweet. So yeah, this is like a mobile Vue-based component framework that you can use to build mobile applications. There's also a Quasar framework, which is another Vue-based mobile application framework. And there are a lot more, actually. I think recently there was a project called Vonic, which is like Vue mobile application with Ionic styles. And if you want to go even further, we also have Weeks, which is, so this is basically React Native for Vue. And we are in the process of working on integrating it. I actually have a local branch that's actually using Vue 2.0 as the runtime for Vue. And if you look at the source code of Vue, you will see that under source platforms, there is this Weeks directory, which we build this alternative build that targeting Weeks with some of its platform-specific things. Yeah. Vue native, yeah. But we make a bunch of different design decisions because, for example, React Native has a lot of React Native specific APIs, and we try to do that as little as possible. We want to allow you to use Vue Router and Vux inside your Weeks applications. You basically have exactly the same, development paradigm instead of only being able to share components. So, but there's a lot. We do have a roadmap. I think it's this one. Wait, roadmap here. Yeah. So we have 3 milestones where we are currently around almost done for 2. I mean, we already have. If is anyone interested in seeing a live demo of how Weeks work? Yeah. Okay. This is an iOS project that's using Weeks. Like, it's already all set up, so I'm just demoing what you can do here. So under Weeks, if we look at the examples, there's a Vue directory. So this Vue directory and the index is just a Vue component. So yeah, so the index is a Vue component, and if we build and run the app, it might take a bit of time. Oops. So Vue examples. So everything here is written with Vue, and it just looks like a native app. And this is all native rendered. There's no web viewing here. Even supports things like animations, translations, and it's pretty performant. Oh, how do I go back? Oh, there you go. Yeah, so currently this project is internally used at Alibaba, which is like the biggest e-commerce company in China. They just started working on it as an open source project like earlier this year. So the development experience isn't quite there yet. They're basically like trying to validate this whole thing in their internal usage before putting a lot of effort into offering a smooth experience that's kind of like what Vue does, and we're trying to make that happen. So we're having this collaboration where first step is making Vue the actual JavaScript runtime so that we use the exact same template parser share the code base. So all the same syntax, all the same like features like slots and stuff, that's going to work. The only difference is going to be the platform-dependent parts like CSS or animations. These things will have a little bit of platform-specific APIs in there, but most of the Vue core features will be largely the same. And this is the iOS demo. There's also Android, and you can even run the thing in the web with hot reload and stuff. So you can develop it in the browser with Chrome Inspector and all that, and then test it on mobile. And because most of your app logic is done in the JavaScript runtime, as long as your app logic is correct and you trust the native renderer, the development experience can be pretty smooth. So yeah, that's it for Weeks. And our next step, so once we finish the integration work, our next step is to basically push out more tutorials and better CLI experience, basically help you to understand how to get started. Right now, like it's still kind of a pretty tedious process, but hopefully that will improve in the future. Yeah. Okay. Any questions? And that whole demo just now was just all Vue files. So same thing. I also recently had this idea of compiling Vue files into native web components. So once you have this like shared spec of how components is written, there's really a lot of possibility you can do. And I'm pretty excited about that. Yeah. Okay. Thanks.
Que la famille.